This problem from two-dimensional probability distribution, and the problem is two numbers chosen at random between 0 and 2. What is the probability that their sum is less than 2, whereas sum of their square is greater than 2? Okay, so here we use uniform probability distribution, and it is given that two numbers are chosen between 0 and 2. So if we draw a rough sketch of x-axis and y-axis, this is x-axis and this is y-axis. Let this is 0 to 2 and this is also 0 to 2. Okay, and let x and y are two number chosen in 0 to 2. Okay, so marginal PDF of x is fxx, which is given by 1 by 2 minus 0 for 0 less x less 2 and 0 elsewhere. Okay, and similarly the marginal PDF of y is given by fyy, this is 1 by 2 for 0 less y less 2 and 0 elsewhere. Okay, and since two numbers are chosen, one number on x-axis and another number on y-axis, so these two random variables x and y must be independent, right? So the joint PDF of xy is given by fxy, which is fxx into fyy. Okay, since this is independent, and the region is looks like a square. This is 2, 2, right? So we get joint PDF is 1 by 2 into 2. This means 4 for 0 less x less 2 and 0 less y less 2, and this is 0 elsewhere. Now we have to find our probability that the sum is less than 2. So we have to find the probability of x plus y less than 2, and together with sum of their square is greater than 2. So x square plus y square greater than 2. We have to find this probability. Now we try to draw these two regions, okay, in the same picture or same image. Clearly x plus y, this is less than 2. This means the line is this. Also this point is 2, 0 and this point is 0, 2. Okay, and also for this region x square plus y square, this is greater than 2. So we draw a circle of radius 2 with center at the origin. This is center 0, 0 at the origin, and the circle is looks like, if we draw here, this is given by the circle. We draw the circle in the first quadrant only because our original range is 0 to 2 and 0 to 2. So we have to record only the first quadrant. Okay, and this is the radius. Let this is O, this is A, this is the radius root 2. Clearly the coordinate of this point, let it be A, this is root 2, 0, and the coordinate of this point, let it be B, this is 0, root 2, right? Now we have to find out the probability of the region. We set the required region. This is our required region. Okay, and this probability can be evaluated by taking the probability as probability of x plus y, this is less than 2. So we get from this probability the probability of the total region. that is the total triangle. Now we subtract the probability of this region, okay, then we get the probability of our required region. So this is x square plus y square less equal to 2. So we first find out the probability of this region minus we take the minus probability of x square plus y square less equal to 2 and then get the probability of our required region. Okay, and now the first probability can be written in the form as, if we take x, this is equal to 0 to 2, then we take this is y, this is equal to 0 to 2 minus x, because y is less than 2 minus x, and this is f xy dy dx minus, here we done, this is integration x equal to 0 to root 2, because the range from 0 to root 2, and we take y, this is equal to 0 to root 2 minus x square, because y is less equal to root 2 minus x square, and this is also f xy dy dx. Okay, now f of xy, this means 1 by 4 in both the case, so we put the value here 1 by 4 and here also 1 by 4. Okay, now integrating with respect to y first, we get this is integration 0 to 2 and we get this is 1 by 4 into, by putting the range directly, 2 minus x dx is remains, because we integrate with respect to y first, and from the second integration we get this is 0 to root 2, and also from here we get 1 by 4 into root 2 minus x square dx. Okay, and the integration of this is 1 by 4 into 2x minus x square by 2, and the range is 0 to 2, minus this is 1 by 4 into the integration of this term is look like this is x into root this is 2 minus x square by 2 plus this is a square by 2. A square means 2 by 2 into sine inverse x by a, so this is x by root 2. Okay, and the range is 0 to root 2. Now putting the range into integration, we get 1 by 4 into 4 minus 2 minus 1 by 4 into the value of this term is 0 in upper range and lower range also. So the contribution of this term is 0, and plus this is sine inverse root 2, so this is pi by 2. Pi by 2 minus 0, so we get this is pi by 2. So our result is, from this term we get this is equal to half, because 2 by 4, and from here we get pi by 8. Okay, so we get the value of this integration is half minus pi by 8. This is our required result. Very important integration, and this is a problem from two-dimensional probability distribution. Okay, thank you for watching.